Hey Astro fans, you may notice that I am somewhere new this week. I'm back from Edinburgh and I have moved into my new house in Oxford, so who knows, maybe you'll see one of my Astro housemates in the future. Now, you may not have heard of the subject of this episode before, but I wanted to talk to you about it because, well, you'll see why it's relevant next week, plus it's just really cool physics. I was blown away by it the first time I heard about it, and I still think it's really impressive. Okay. The Yarkovsky Effect. The Yarkovsky Effect is an effect caused by sunlight falling on asteroids. Asteroids rotate as they go around the sun. Let's use this avocado to be our asteroid. As it rotates, one side is absorbing light from the sun, and as it turns round, this light is emitted as heat, as energy coming from the other side. And it keeps doing this as it keeps on spinning. What this does is when the heat is emitted, this actually gives the asteroid a little push. And it depends on which way the asteroid is rotating as to how it affects its orbit. Say the asteroid is rotating in a clockwise direction around the sun. So if you have your sun here, and the asteroid is going round, and then the way that the asteroid is spinning on its own as it's going round is also clockwise, this is called a prograde orbit. And what happens with the Yarkovsky effect on a prograde orbit object is that it spirals away from the sun. However, your asteroid could still be going clockwise around the sun, but instead of rotating in the same direction, it's rotating in the opposite direction. So it's rotating around anti-clockwise, but it's moving clockwise around the sun. This is called a retrograde orbit. And the Yarkovsky effect on a retrograde orbit object is that it spirals in towards the sun. We see this elsewhere in the solar system too. Venus and Uranus are also on retrograde orbits. So what I've just described is one component of the Yarkovsky effect. This is called the diurnal effect. I think I've pronounced that right. And this is the dominant effect that takes over on large objects that are wider than 100 meters. But there is one other effect too. This is called the seasonal effect. And this takes over from the diurnal effect if the object is smaller than 100 meters or if its axis of rotation is close to 90 degrees. And what I mean by that is if you have your normal asteroid rotating this way that we just spoke about with the diurnal effect, its axis of rotation would go straight through the avocado, and that would be at a tilt of 0, so it would be straight up. However, if you change that to 90 and you kept the avocado spinning, you have something very different facing the sun. And so you get much longer heating, because instead of what we had before, which is where you have the asteroid rotating pretty much all the time, showing a very different face quite regularly to the sun, you instead have this more fixed object that doesn't rotate. So it does see the two different north and south poles of the object as it goes round, but you get much longer heating in a case like this. So if the sun is here, imagine that this is still rotating round, but it goes round like this, and that is how it would be that you would then get the south pole then facing the sun. It's quite a handy diagram if that didn't make sense, because it is quite a few things to think about. And with the seasonal effect, it doesn't matter which way your avocado is spinning. It always gets pushed to spiral inwards towards the sun. As you can imagine, being pushed around by tiny photons of light isn't the strongest way to push an asteroid. For example, the Yarkovsky effect on an asteroid called Bennu is about 15 grams. So that's 3 grapes. But the weight of that asteroid is 68 million tons, which is roughly 10 million large male African elephants. So the difference is pretty big, and it takes millions of years for something really substantial to happen. But it does still make an effect on the orbit, which would be pretty important if you were going to send a mission there. Until next time, keep being curious.